이번 영상은 셀레스티아 팀의 COO이신 닉 화이트님의 두 번째 인터뷰 영상입니다. 첫 번째 영상을 보지 않으셨다면 상단의 영상 참조 부탁드립니다. 다른 의미 있는 설립자들의 인터뷰를 위해서 좋아요 그리고 하이프 부탁드립니다. So let's go to a little bit more technical. So what is data availability sampling and why is it so important?
So data availability sampling is one of the core technologies that Celestia has implemented. It was the first protocol to ever implement data availability sampling. And what it is essentially this cryptographic primitive, an innovation that I think was invented in 2018. Okay. And actually the founder of Celestia, Mustafa Al-Wassam, before he wrote the Lazy Ledger white paper, the Celestia white paper, he wrote a paper introducing this concept, co-authored with Vitalik from Ethereum. And this cryptographic primitive is basically a solution to the scaling problem for blockchains. So let me just quickly introduce what is the problem when you try to scale a blockchain.
Okay.
Well, in the typical design of a blockchain, well, how does it work, right? Blockchains are computers that anyone can run and verify. And because of the fact that anyone can verify what's happening on chain, you can run a node and you can see everything that's happening on Bitcoin. You can see everything that's happening on Ethereum. It's a totally public, permissionless system that everyone can validate and audit, right?
Yeah.
That's where the security, that's really where the power, the core property that blockchain provides this verifiability. Now, the problem is that if the way that you verify a chain is by downloading every single transaction that happens globally and re-executing every transaction that happens globally, you're going to run into two bottlenecks. One is, as there's more and more transactions, you won't have enough computer power to actually keep up with all the transactions that are happening, right? Like on my laptop, I can't process 1 million transactions per second. I don't have enough computer power. And then the other problem you're going to run into is, even if I could process, I did have a fast enough computer to process all those transactions, I would need a really fast internet connection to be able to download all those transactions in the first place.
Yeah.
So those are two bottlenecks in scaling blockchains. One is I would call execution. The other was what we would call data availability, which basically means, how much data can I actually verify. So this is where it gets a little bit tricky. So now, so if we want to scale blockchains, we either require everyone to have a really massive computer with a lot of bandwidth, which obviously is not feasible, right? If we have 1 billion users on chain and there's like tens of millions of TPS, no one will be able to run a node. No one would be able to afford to run a node. And so then we fall back to the old world where only Google can afford to run a node, and Amazon. And so now we're back into the same trusted system that we tried to avoid. The other way, and this is where people have been banging their heads against the wall trying to solve this problem, is like, is it possible to build a blockchain in such a way where if I want to verify the chain, I don't actually need to download and re-execute every transaction? And for a long time, the Bitcoiners were talking about this. They thought it was impossible. But as it turned out, the missing key was this idea of data availability sampling. So as far as like the execution part, right, you can do what rollups do, which is have a proof that all the transactions were executed accurately, either with fraud proof or something called a zero knowledge proof. Your audience probably will know what that is. But then you're stuck with this problem, which is, well, you would still need to download all the data of those transactions in order for the fraud or ZK proof to be secure. So we need a way to, but you don't actually need to download it yourself. You just need to know that someone somewhere could have downloaded it. And that's the innovation of data availability sampling is like, I can verify that the data was available, meaning it was published publicly on the internet, on the protocol, and anyone who wanted to could download it at some point in time. And I can verify that in a way that is extremely efficient, and does not, no matter how big the block is, it basically is still the same amount of effort for me to verify that the data was available. And so that's what data availability sampling is it solves that problem and thereby solves one of the core bottlenecks to scaling blockchains that had been basically assumed was impossible to solve. And it's a very, very clever technique. I could describe more about how it actually works, but I don't know if that's really necessary.
Yeah, I think I often think that like because of data availability sampling, so the users can actually have verifiability in their hand, I think. So when it comes to Ethereum, you need to put up like lots of ETH, and then you can actually check the transaction actually was okay or not. But with data availability sampling, you can actually check as long as you have a phone or any device, minimal device, you can actually check the transaction was okay. Is that okay? Is that okay take, you think?
Yes.
Okay.
Yeah,
Cool.
so I think that's a really good way to put it, but it's also not even necessarily that, I think it's amazing, right? If someone can verify everything happening on chain on their phone, you can't really get more decentralized than that. Because literally every single person at any moment can just see everything that's happening on chain and not just trust. Even today, like, when most people interact with the blockchain, they use the block explorer, which is run by some centralized company, or they use an RPC service to interact with the chain and read their account balance. Like they open their wallet is not actually verifying anything that it's displaying to you. The wallet is asking some other third party, centralized third party, how much money is in this account. So those people can lie to you, right? And so you could accept a payment because your wallet updates, and then it turns out, and then you give, I say I'm selling my car, and I give the guy my car because I see like, oh well, USDC showed up in my wallet. But it turns out then actually the RPC provider who's telling my wallet what number to show me lied, right? Versus a world where I'm running a node in my wallet, and there's no intermediary. It's just me and the network and all the other nodes, and that is really the ideal trust model. But it's not just about that. It's also just about the fact that, not every user. We'll see how things play out in the future, but maybe not every user is going to really want to run their own node. But if I'm a business and I'm settling transactions, I'm going to want to run my own node so that I can actually be sure that all the data that I'm seeing, like the power users will definitely want to run nodes, I think. And not even necessarily power users, but people, the more value that you're transacting on chain, the more, money or what have you, value that's at stake on chain, I think the more incentivized you will be to run a node. And we just want to make that barrier to entry as low as possible. And that's always been like the vision for blockchains. Like, if you read the Bitcoin white paper, it's all about, everyone should be running a node. Originally in the Bitcoin and Ethereum communities, it was a given. All the wallets actually had a node embedded in them that you had to sync.
Yeah.
But it was just as those chains got bigger and bigger, it became infeasible and like unpractical for people to actually run their own node. So it's kind of like a part of the cypherpunk original vision that's been lost over time, but I think is essential. And maybe not, it doesn't feel essential now, but again, as more and more of our lives are on chain, I think it'll become more and more important that these systems are robust and decentralized. So it will be more and more important that people run nodes.
I think that in this point, we need to clarify one thing. I think people often think that data availability sampling or because of the name, I think that people often think Celestia is like Filecoin. You know what I mean? Like they think that, oh, the Celestia node it's sort of like a data bank. They often think it's a data bank, but it's not. It is not data bank. And often you describe like the name, the language called what's it called? Publishing. I think that data publishing is a better word for explaining things. Could you explain that part?
Yeah. That's a really good point. So there's a few things that are really important to clarify here. One is, people hear data availability, or they hear Celestia is a data availability protocol or layer, and they think that, oh, well, that means like it's data storage. It's like Filecoin, or Amazon S3. It's just a decentralized version of like some kind of data storage service.
Exactly.
That is completely wrong. Like Celestia is, the best way to think about it is it's an L1.
Yeah.
It provides going after the exact same market and architecturally, the same, trying to achieve the same goal as an Ethereum or a Solana. It is a general purpose application, like blockchain, to support people who want to build applications. The difference is that it just doesn't do smart contracts. It just provides you the raw block space. So think of it as like Ethereum sells block space, Solana sells block space, Celestia also sells block space. And that's very different than being a data storage layer. Now, why is it data publishing? Why is that a better mental model? Well, data availability, I think it's just a bad name, but unfortunately one that just stuck from the early days.
Yeah.
But data publishing is a lot better of a word for it, because what you're trying to verify, you're not storing data. That's not what making data available is. You are, it's kind of a tricky concept, but you're making sure that data has been published publicly so that anyone can download it. It's kind of the difference between a library and a newspaper, right? A library is a place where, if I give you let's say I wrote a book, I hand it to the library. I read an article. I hand it to the library. That library is going to say, oh, great, thanks for the article. I'm going to store it, down in the archives. And if anyone needs it in the future, I guarantee you that I will be able to give it to them. Right?
Yes.
A newspaper, and that's what data storage is. It's basically, I promise I'm going to hold on to this data in case you request it in the future.
Yes.
Data publication is a newspaper. I wrote the article. I want everyone in the world to see this. I publish it on the newspaper, and it gets distributed out to everyone in the world who's a subscriber. In other words, everyone who's running a node of that network. So that way, I know that information is disseminated and it's public information. If I publish something on a storage layer, it doesn't mean that it's public or that it's disseminated. There's maybe one guy storing it, right? Yeah. But it's very different to like having my article go out to every corner of the world. And that's the guarantee that you need, right? Because what you're trying to guarantee is that anyone, if they wanted to, could verify this blockchain. So how do you make a blockchain verifiable? Well, all of the inputs, all of the transactions, everything that's happening on that blockchain needs to be public information. so that anyone could download it and re-verify it. And so that's why you're trying to make sure that that information is out there in the public so anyone can see it. You can think of Celestia sort of like now the difference is that Celestia is sort of like a magical newspaper where you can put more and more and more and more articles in it, but it stays the same size. Mm-hmm. So, you could have 10 million articles that you publish in that day's paper, meaning that day's block. And instead of every subscriber needing to read, if that newspaper would be like, it would weigh a ton, it'd be the size of a car, right? Mm-hmm. But the beauty is because of data availability sampling, you can publish all those articles, but keep the newspaper the same size for each end subscriber. So that's why I can still subscribe to the network and verify everything that's happening without it getting too heavy. And a last way to think about this is that what's actually happening under the hood is you're essentially sharing the work. Everyone that's a subscriber on the network is doing some small part of verification, but then because there's enough people verifying each of their own small part, it ends up verifying the whole piece, the whole block. So it's kind of like a way of sharing the work rather than the old world where everyone had to duplicate the same work to verify something.
Yeah. So let's move on to the comparison then. So what are the key limitations of the current smart contract layers in terms of launching applications?
So I put it in maybe three main categories that come to mind for me.
Okay.
The first is just execution.
Yeah.
Meaning, okay, let's say you're Ethereum L1. You have already sort of baked in this execution environment called the EVM, the Ethereum Virtual Machine. Yeah. And that means that you support a specific kind of specific operations, right? And that defines how much certain operations cost. It defines what is even just possible to build. And that means that it's a very limiting thing. It kind of like, again, like that drawing analogy. It's like the EVM drew an outline of like, this is where it's okay to color.
Yes.
And if you go out here, you're just not allowed to do that.
Yeah.
From a business logic perspective.
Yeah.
And so that's very limiting. It's much better if someone can define their own virtual machine or not even have a virtual machine and literally just write straight up Rust code that implements their business logic. And so that's the kind of thing that's possible when you like step outside of this monolithic design. That's one thing, execution flexibility, right? The second thing is, I would say, sequencing.
Yeah.
So what does that mean? Well, if I'm transacting on Ethereum L1, the user sends their transaction to the broader network of Ethereum validators. And then the validators decide how to order everyone's transactions.
Yeah.
It turns out that the ordering of transactions is very important. It is where MEV comes from. It's also what gives you the latency, right? Of like how fast is my order confirmed as a user, so that I know that what I'm trying to do is got done. Like how fast do I get the response? And it also can be important for use cases like say you're building an exchange. Well, you want to make sure to prioritize certain types of transactions and deprioritize other ones. So Hyperliquid famously does this, something called cancel order prioritization, where because they're trying to make the marketplace more advantageous to market makers, they make it so that if you're canceling an order that's already existed, you get a priority over people who are trying to fill that order.
Okay.
And this is actually one of the key things that's enabled Hyperliquid to be as successful as it is today. And again, if you're building an L1, a monolithic L1 like Ethereum, those things are already decided for you.
Yes.
Like how fast you're going to get confirmation? Well, you have to wait for a block, the block time of the underlying L1. How is the transaction going to be ordered versus other people's transactions? Not up to you at all.
Yes.
Already predefined by the L1. So sequencing is a really also MEV.
Yeah.
Do you want to leak all the MEV to this base layer?
Yes.
The Ethereum validators, or do you want to capture the MEV for yourself and redistribute it to users, or maybe implement some kind of special thing that tries to mitigate MEV, right? So that's a huge one, and we're working with a lot of teams who are, doing custom sequencing rules like what Hyperliquid is doing. There's a lot of other very interesting ones that are trying to build verifiably fair ordering schemes and things like that. A lot of teams again want to capture MEV because that's a lot of money. Like why would you just give that away to Solana or Ethereum? It doesn't make sense. If you're bringing the transactions, you're bringing the users, you're bringing the liquidity and activity, that's kind of makes sense to belong to you. So sequencing is a big one. And then the last one is like the wallets and like the cryptography and the user interaction and interface. So if you build a monolithic chain, they already have a certain signature scheme. They have a certain kind of transaction formatting. They have certain wallets that they support and things like that. And that limits how users can interact with the chain, like your app. So if you build an app that's on that shared L1, you inherit those constraints. Now, in some ways, you see that as an advantage in the sense of, okay, well, a bunch of people already have installed MetaMask and they already have some Ethereum in their wallets. So it's going to be, you can almost think of the L1 in that case as a distribution platform. It gives you distribution to all these users, like a pre-downloaded, pre-installed user base. But so yeah, you can think of, an L1, a monolithic L1 as a distribution platform because all the users have already downloaded the wallet. They might have funds in that wallet, etc. But again, you're now sort of stuck within the confines of that ecosystem in a sense. And like, so an example of what I mean is, why don't we have like cryptography on our phones. We have secure enclaves, we have passkeys and all these things that actually make using private keys on a daily basis very secure and very user friendly. But for some reason we can't, we still don't have those kind of wallet experiences on Ethereum L1 or Solana L1 and many other L1s today. And it's because they made certain decisions around how their private key infrastructure works that limits that, right? And so a project that we work with closely is called Pay.
Yeah, Pay is awesome.
Yeah, really cool app. And one of the things that they did is made their wallet and their cryptography compatible with the public key, like private key sort of like infrastructure on your phone. So you never have to set up a seed. You never have to write down your seed phrase. Your wallet is just spun up natively in your secure enclave, as a passkey. You can sign using Face ID. It gets backed up in iCloud or whatever, if you're an Android, the equivalent service. And it is a completely seamless Web 2-like experience. And so anyway, the only reason they're able to do that is because they're not building on Ethereum L1. They built their own chain and they could customize all those features. And also, aside from the fact that, you can make those kind of choices, I think, owning the wallet layer also allows you to more closely own the end user relationship. And that's also why we're seeing a lot of apps now shift to an embedded wallet, like a Privy style thing, where people, first of all, it's easier. People just sign up with their email and whatever, but also they get to have a direct relationship with their user base in a way that you don't get if you're just a smart contract, right? The L1 is the one that kind of owns the user. The L1 wallet is the one that owns the user in that case. So those are three big ways in which being a monolithic chain is very limiting, I think, for application developers.
So next question.
Yes, absolutely.
As you know, tribalism is quite prevalent in crypto. People are fighting on Twitter for their bags all day. How do you describe the relationship between Ethereum and Celestia? Are you guys competing or helping each other, or how do you see it?
Yeah, great question. So, Mustafa co-wrote the data availability sampling white paper with Vitalik. A lot of the ideas that turned into Lazy Ledger and Celestia were actually incubated on the Ethereum research forums. And so there's a lot of philosophical alignment between Ethereum community and Celestia, where I think, so there's just very, very aligned. I think that Celestia is not a competitor to Ethereum. It's sort of like Ethereum is not a competitor to Bitcoin. They're just kind of different things. That's the way that I see it. I do think that Ethereum is now pursuing a more roll-up centric roadmap, which does bring it, means that it's moving towards a design that is much more similar to Celestia. And that's, I think, actually a really massive validation of the Celestia thesis, that the second biggest project in the industry is essentially pursuing the same design. But the thing is that Ethereum has all this monolithic, I don't want to call it baggage, but the existing monolithic chain and design and all the things that come with it in a way that kind of holds it back from ever, I feel, going fully modular, where Celestia got to start from scratch and redesign everything. And then on top of that, because Ethereum has so much like an existing user base and all that, it is just much more difficult to move fast and to scale and to implement these changes. Celestia can be much more nimble because it has less of that baggage. But I think Celestia is like the real competitor for Celestia is something more like Solana. So that's kind of because Solana is like this really high performance chain. And I think Celestia is really trying to go after not only this rollover, so just really massive high throughput. And again, we already actually have a chain that has significantly more throughput than Solana does today. So, and I expect us to like only accelerate and continue to widen the gap of the kind of throughput that Solana can do versus Celestia, because just architecturally, again, we don't do execution, so it's much simpler.